Good morning, dear students. Let's start new chapter, chapter 6. It is chemical thermodynamics. What is thermodynamics? Thermodynamics deals with the heat changes, different forms of energy, and their quantitative relationship between them. Okay, if you will see the word thermodynamics, thermo means heat and dynamics means study of motion. What we mainly study? We study about heat and we can study about heat and energy, but mainly we study about the heat. So, what is chemical thermodynamics? Chemical thermodynamics deals with energy changes in a chemical reaction. This chapter will become quite easy when we will understand the terms, small terms, which will be used throughout the chapter. So it will be easy for you all that whatever term we will use further in different laws, and you are knowing the definition and properties of that particular word, then it will be easy and it will make interesting also to understand the whole chapter. So let's start with the term system, surroundings and boundary. Suppose I am heating or something in a conical flask. Okay. So the work which I am doing, this will be our system. Okay, the thing which I am doing is that I am heating a water in a pan, container or any flask. This is the work I am doing and this will be my system. And what will be surrounding? Surrounding means not only the laboratory, Gorakhpur, Uttar Pradesh, India. I am surrounding means the whole universe. Universe means the world, the stars, the moon, the galaxy, the whole surround. This will be termed as surrounding. The whole universe will be our surrounding. The work which I am doing, that will be my system. And there should be a differentiation between this system and the surrounding. So the line which will be drawn between system and surrounding, that will be considered as a boundary. Okay, so the part of universe which is under experimental consideration is called system, and the part of the universe except system is called surrounding. The real or imaginary surface which separates the system from the surroundings is called the boundary. Now let's see types of systems. There are three types of systems: isolated system, closed system, open system. What is isolated system? It is a system which cannot exchange matter and energy with the surrounding. Okay, here you can see that isolated system. Have you ever seen this isolated system? I think when you was coming to school regularly, you have seen this isolated system, because the water bottle you were bringing, that was your isolated bottle. Many of you are using the thermos flask, that Milton water, whatever. If you are bringing cold water, it would have remained cold till the last bell if you will save the water. So the flask which can keep cold water cold, warm water warm. Why? Because there is no change or because the exchange of matter and energy is completely prohibited. So that system is known as isolated system. Closed system, it is a system which can exchange energy but not matter. In this flask, if it is a hot water in a closed glass bottle, it is closed, so mass cannot be changed, but heat I can increase or decrease. So this type of system will be considered as closed system. What is open system? It is a system which can exchange both energy and matter with the surrounding. Okay, for example, hot water in an open beaker. Here conical flask is here, water is being heated, and it is open flask. I have not covered it with any lid. So this will be our open system. So I hope it is clear to you all what is isolated, thermos flask, closed when water is being heated and it is closed, open system when water is being heated and the container is not enclosed anywhere. Okay. And on the basis of composition, there are two types of systems: homogeneous systems and heterogeneous system. Homogeneous, a system is said to be homogeneous when it is completely uniform throughout. It is made up only of one phase. For example, aqueous solution of sugar, glucose, etc. That will be your homogeneous system. And heterogeneous system, a system is said to be heterogeneous when it is not uniform throughout. That is, it consists of two or more phases. For example, ice in contact with water. This will be a heterogeneous system. Now let's see the macroscopic properties of system. The properties associated with the bulk quantity of matter are called macroscopic properties. And these properties are of two types: intensive properties and extensive properties. First, let's see what is intensive properties. The properties whose magnitude does not depend upon the quantity of matter present in a system is called intensive property. Pressure, temperature, density, specific heat, viscosity, refractive index, surface tension, boiling point, etc. These all are intensive property. Means the properties whose magnitude does not depend upon the quantity of matter. What is extensive properties? The properties whose magnitude depends upon the quantity of matter present in the system are called extensive properties. For example, mass, volume, internal energy, entropy, etc. Try to understand with this example what I am giving you. Suppose, let's draw here. I have a container and this container is filled with air. Okay. And now what I am doing, I am just using a shutter and just bifurcating it. I am dividing this container into two by using a shutter. So, if whatever the volume of gas was prior, it was V. Now, what will happen? It will become V by 2. It will become half as I am bifurcating it from the center. So, volume is changing here. So, it is extensive property. Pressure is not changing, temperature is not changing. So, that is intensive properties. Okay. Now let's move on to state functions, or we also call it state variables and path functions. Those macroscopic properties which can change the state of a system is called state variables. Change of state, that you can understand that a child, young, adult, old, these are the stage of changes in any human being. Like that only our system also changes, and the variables will be pressure, volume, temperature and composition. Suppose in a container I have filled a gas at constant pressure, volume will be there of that gas, temperature will be there, and if I have mixed many gases, then the number of moles of all the gases. So these are the compositions and amount, and that can be variable. So those macroscopic properties which can change the state of a system is called state variables. Pressure, volume, temperature, composition or amount, internal energy, entropy, and enthalpy are state functions. Why? Because we can describe the state of a system by quoting these variables. You have to remember that heat and work are not the state functions. The functions which depend on the path followed are path dependent functions. For example, heat and work. Now let's see thermodynamic processes. What are thermodynamic processes? A thermodynamic process is said to occur when the state of a system changes from one state, that will be its initial state, to another state, that will be its final state. Few different types of processes are, let's see, number one, reversible and irreversible processes. Reversible and irreversible processes. So, on the basis of nature of change by which a system travels from initial to final state, this process is divided into two types: reversible process and irreversible process. As you are familiar with the word reversible, irreversible, reversible means it is an ideal process which takes infinite time to complete. Means any work which have been started, and it can go throughout the years and years, decades and many millennium years. That slow process is a reversible process. And what is irreversible process? It is a spontaneous process and takes finite time to complete. Okay, and this cannot be reversed. Try to understand with my this example. Suppose you take a stone and tie it with a thread, and you go on the ceiling or chat pe on your house, top of your house. You reach there, and as you have tied the stone with the thread, you can just drop that stone from the top to bottom, and anytime you can take it back as it is tied with a thread. So this will be your reversible process, and any time the system can be reversed. But if suppose you have not you are not holding the thread, you have just thrown the stone to down to the ground, what will happen? It will first go down, then only you can start any other work to do with it. Okay, so throwing the stone from the top on the ground without holding it with a rope or thread, that is your irreversible process. And when we are throwing the stone by tying it with a thread and holding the thread, that will be your reversible process. Okay, next is cyclic process. Cyclic process is one in which the system, after performing a series of operations, return to its initial state. After doing all the processes, it is coming back to its initial state. A cyclic process may both be reversible and irreversible, depending upon the manner how it is carried out. How we are performing it, it depends upon it. So the net work done in this process will be 0. Next is isothermal process. It is the process carried out at constant temperature. Isothermal means temperature is constant here. And for this process, the system is usually kept in contact with thermostat. Next is adiabatic process. It is the process in which heat cannot leave or enter the system. that is dq will be 0. For this process, the system is thermally insulated from the surroundings. Next is isobaric process. Isobaric process, it is the process carried out at constant pressure. dP will be 0, and all reactions carried out at atmospheric pressure are example of isobaric process. However, volume change always takes place in this process. When we will perform anything under the atmospheric pressure, the volume can be changed. Next is your isochoric process. It is the process in which the volume of system is kept constant, means dV is equals to 0. So these are your processes, different type of processes. Next is thermodynamic equilibrium, that I will discuss in my next lecture. So in short, all these systems and terms are given in this table, that it can help you for your ready reference. You can note down in your copy. System, let's revise it again. System, part of the universe under investigation, means whatever work I am doing, that is my system. Open system, a system which can exchange both energy and matter with its surrounding, means water is being heated in a pan. Closed system, a system which permits passage of energy but not mass across its boundary, means a pan which is closed is being heated. Isolated system, your thermos flask, a system which can neither exchange energy nor matter with its surroundings. What is surrounding? Part of the universe other than the system, the water which I am heating in the pan, except the whole universe is my surrounding, which can interact with my system. Boundary, anything which separates system from surrounding. State variables, the variables which are required to be defined in order to define state of the system, that is pressure, volume, mass, temperature, surface area, etc. State functions, property of system which depend only on the state of the system and not on the path. Intensive properties, extensive properties. Intensive properties of a system which do not depend on mass of the system. Extensive properties of system which depend on mass of the system. Process, path along which system of a state of a system changes, that will be our process. Isothermal, temperature constant. Isobaric, pressure constant. Isochoric, volume constant. Adiabatic, no change of heat, process during which transfer of heat cannot take place between system and surrounding. Cyclic process, the point from which initial point again we reach back to, after the process we reach back to the initial state. Reversible, which can be reversed, and it is a slow process. Irreversible, which cannot be reversed, and it has a finite time, and all the natural processes are of this type. Okay, so in my next lecture I will take some of the other points, thermodynamic equilibrium, internal energy work, and all these things, before moving on to different laws of thermodynamics. Okay, read this children, and let's meet in our next lecture. Thank you so much children.